Hi friends, let us learn the chapter called Vectors, which is for Inter first year of state syllabus. Okay, actually this chapter is very easy if you understand. If you didn't understand, it can be hard, but later you can understand it. So no need to worry much about this chapter. Before starting to learn about vectors, we must know what is a physical quantity. Actually, it is a type of quantity which can be measured, like which has some magnitude and which is an quantity. Like we can give example time which can be measured in seconds, then speed, then distance, like many example, etc. Actually, which can be measured. I mean, it has some magnitude. That is called an physical quantity. Now, this physical quantity is divided into two types. One is scalar quantity and another is vector quantity. For you, I am going to write this definition, which can be measured. There are two types in physical quantity, those are scalar quantity and vector quantity. Actually, there are many types, but according to chapter vectors, we shall discuss this only now. Okay, now what is scalar quantity? You might have read in 9th or your 10th classes, but again, we will just clear this. A physical quantity, scalar quantity is a physical quantity which has only magnitude but no direction. See friends, we can say like time. We know time we can measure in seconds or if you want in minutes, but we cannot say the direction, as well as mass, length, more charge, time like temperature. These have only magnitude which can be measured, but we cannot say the direction. Then this is just opposite of that, but a slight difference. A physical quantity which has both magnitude and direction. It will have some magnitude as well as direction, like velocity we can say in meter per second and at what direction it is traveling, and we can say force or momentum or displacement, etc. Like, now let us write some examples for this. And here we should always remember that it should also obey some law called vector addition law, which you will be knowing next, but not now. Actually, like according to what now I have thought, if I will ask what is current, we will say that current has some ampere. Current is measured in ampere and it is flowing from negative to positive, or from wire we can say this direction to this, etc. But actually it is not a vector quantity because it does not satisfy vector addition law. So now no need to know much about it, we will know afterwards. But just to remember that like current cannot be taken under as vector quantity. Okay, now let us write some examples like mass, length, time, you can say charge, temperature. Actually so many are there, but I'm just giving a few to make you understand. And examples are in vector quantity: displacement, we have velocity, and force. Yes. Okay, but like I have said that these have only magnitude, these have magnitude as well as direction. Now let us try to know what is magnitude. Like magnitude we cannot say, like we cannot have a proper definition, but like definition is magnitude is defined as a number. It can be any number like 10, 20, 100, any number, followed by its unit. A number followed by its unit. Like examples, like weight. In like weight is suppose 10 kg. 10 is the number, kg is the unit of weight. And then time. 10 seconds. Like 10 is number, seconds is unit. We can take many examples. Now let us proceed to types of vectors. Let us write the heading like types of vectors. Actually it is very easy, but you have to put a little bit concentration, then everything can be easy. First is like vector. Like vector. Like vector has same or different magnitude. It can be, the magnitude can be equal or different, no matter, but its direction is same. It must be same. Then it is called as like vector. Like vector we represent by a arrow and a mark, like we are showing its direction of the particular arrow, but we call it as vector, not an arrow. Like example, here we can see the magnitude is not equal, but the direction traveled by it is same direction. Magnitude can be very less or more, it doesn't matter. Okay, now let us proceed further. Next is equal vector. Like you might have understood, like which has same magnitude. We can come to know from here only. Equal means same, which has same magnitude and direction. Direction is also same as well as magnitude is also same. Like example, we can show like this, or we can show even like this. But remember, the magnitude must be same. Like this is 5 meter, this is also 5 meter, or like if this is 10 meter, this is also 10 meter, but it should be same. Remember that always. Then next, parallel vector. Parallel vector. In parallel vector, vector should be parallel to each other. By name only we can know. Vector should be parallel to each other. Like, and direction must be same. Must be same. Here magnitude can be same or different. It can be anything. We cannot say. Like example, 2 lines. Actually I am not drawing such a straight line. Yeah, these both are parallel to each other, but magnitude is different and they are in same direction. Okay. Now next is third one. unlike vector. Unlike vector. In unlike vector, magnitude, comma, direction, both are different. We cannot say either magnitude or direction is same, but both are different. Like example, it can be like this, one like this, like this. Anyway, as per our definition, we can take like any vectors. Next is opposite vectors. Opposite vectors means its magnitude can be same or not. It can be same or not, but direction should be quite opposite. Like it should be 180 degrees opposite. Should be opposite. Like examples, if one vector is in this direction, another vector should be in this direction. If one vector is in this direction, another vector should be in this direction. The vector should be opposite. And next we will know opposite for a opposite equal vectors. We can say now that magnitude is same. As we have said, it is equal, and direction is opposite. Means one vector's direction is 180 degrees opposite to other. Like here actually it can be different. Here more, like here example is exact. It must be exact, as we are saying the vector is equal. Okay, then next is coplanar vector. Next is coplanar vector means it should be in a same plane. Like in a same plane, I mean it must be in a same plane. Like examples are all the above vectors which I have discussed. Like examples, anything. But like if you are saying it is not in the same plane, like this is x and this is y and z will be like this. We cannot show it on any surface actually, but we can say it is like I can show you with my pen. This is on a surface, this is also on a surface, but z-axis will be like this, like which we cannot show on one plane. This is x, y and z. Z we cannot represent on any one plane. So like coplanar vector means it should be in same plane, like x and y. This is only on one plane, like only on one surface. Okay, so that's it for first class.